Nucleophilic substitution reaction. Firstly, let me teach you the basic concept of nucleophilic substitution reaction. Let's consider this alkyl halide. Now I bring a nucleophile near this alkyl halide. Remember that nucleophile has always negative charge. Here, this nucleophile OH is a strong nucleophile. On the other hand, chlorine is more electronegative than carbon. Hence, it attracts the shared pair of electrons more towards itself. As a result, partially negative charge appears on this chlorine and partially positive charge appears on this carbon. This chlorine is a weak nucleophile. Now listen carefully. This strong nucleophile will replace this weak nucleophile. Let me repeat it. This strong nucleophile will replace this weak nucleophile. Because we all know that strong people always rule over weak people. This is a substitution reaction, or replacing one nucleophile by another nucleophile. That's why we call it nucleophilic substitution reaction. Therefore, we define nucleophile substitution reaction as a type of organic reaction in which a strong nucleophile replaces a weak nucleophile is known as nucleophilic substitution reaction. Let me repeat it. A type of organic reaction in which a strong nucleophile replaces a weak nucleophile is known as nucleophilic substitution reaction. Remember that there are two types of nucleophilic substitution reaction. The first is unimolecular nucleophilic substitution reaction and we call it SN1 reaction. While the second one is bimolecular nucleophilic substitution reaction and we call it SN2 reaction. Thus note it down all these important points. Now let me teach you SN1 reaction. We know that tertiary alkyl halides favor SN1 reaction. So I take this tertiary alkyl halide. Now I place a nucleophile here. We already learned that this strong nucleophile will replace this weak nucleophile. As a result, we get this compound. Now what about the mechanism of SN1 reaction? Well, SN1 reaction occur in two steps. In the first step, formation of carbocation or carbocation is formed. I take a tertiary alkyl halide. Now I add a polar solvent to it, due to which this molecule gets polarized. I mean, this halogen becomes a nucleophile and this becomes carbocation. Here, the angle between carbon atom is 109.5 degree, while there the angle between carbon atoms is 120 degree. Remember that first step is a slow step, hence carbocation is formed in the first step. The second step is attack of a nucleophile on alpha carbon of carbocation. Now there are two possibilities of attack of a nucleophile. I take this carbocation and place it here. Let in the first case, the nucleophile OH attack from the right side. I get this compound. Here, carbocation has retained its original shape 50%. So we call it 50% retention of configuration. It means that this molecule has retained 50% of its original arrangement. In the second case, I take this carbocation and I place it here. Let this time the nucleophile OH attack from the left side. As a result, we get this compound. We call it 50% inversion of configuration. Remember that SN1 reaction is faster in 3rd degree carbon, then 2nd degree carbon, and then 1 degree carbon. Thus, this is the complete mechanism of SN1 reaction. Now let me teach you SN2 reaction. Remember that primary alkyl halides favor the SN2 reaction. Now I take a primary alkyl halide. I place here a nucleophile. This strong nucleophile will replace this weak nucleophile. As a result, we get this compound. Now what about the mechanism of SN2 reaction? Well, it is a one-step reaction. We already know that this is a strong nucleophile and this is a weak nucleophile. It is impossible that A nucleophile will attack on a nucleophile. Hence, I remove this nucleophile and I place it here. Now, this nucleophile will start attacking on this hydrogen. As a result, we will get a transition state. In this state, neither is OH completely bonded to the molecule, nor is halogen completely removed. Remember that this is unstable state or temporary state. Finally, we get this molecule and the halogen is substituted by OH. In SN2 reactions, inversion of configuration occur. Also remember that SN2 reaction is faster in 1 degree carbon, then 2 degree carbon, and then 3rd degree carbon. Thus, this is the mechanism of SN2 reaction. Finally, let me teach you the difference between SN1 reaction and SN2 reaction. Well, SN1 is a first order reaction and SN2 is a second order reaction. SN1 is a first order reaction because rate of reaction only depends on concentration of alkyl halide, while SN2 is a second order reaction because rate of reaction depends on both the concentration of alkyl halide and concentration of a nucleophile. Thirdly, 3rd degree alkyl halides favor SN1 reaction, while 1 degree alkyl halide favor SN2 reactions. Fourthly, it is favored by polar solvents, while SN2 reaction is favored by non-polar solvents. Fifthly, in SN1 reactions, carbocation is formed as an intermediate part of the reaction, while in SN2 reactions, no carbocation is formed. Sixthly, SN1 is a 2-step process, while SN2 is a 1-step process. Seventhly, in SN1, rearrangement of products takes place, while in SN2, there is no possibility of rearrangement. Eighthly, SN1 reaction follow first order kinetics, while SN2 reactions follow second order kinetics. Ninthly, the nucleophile attacks the carbocation from both the sides, although backside attack dominates, while in SN2 reaction, the attack of nucleophile takes place from the backside only. Tenthly, SN1 reaction is favored by weak nucleophile, while SN2 reaction is favored by strong nucleophile. These are the some important differences between SN1 reaction and SN2 reactions. I hope that you have learned all about SN1 reaction and SN2 reaction.